Hi everyone, today we're going to be solving linear equations with the variables on both sides. So I've got two examples. The first one, 7m plus 2 equals negative 3m plus 22. Now firstly, what solving equations actually means is that you want to try and get your final answer to look like this case, m equals something. So that's what we want. So I'll just draw a little box around that. That's what we want our final answer to look like. M equals something on the other side. So if I've got 7m plus 2 equals negative 3m plus 22, first step, let's look at, let me get another color. Let's look at this negative 3m here. Let's try and get that to the other side. If I've got a negative 3m and I want to bring it to the other side of the equation, I need to do the inverse of subtract 3, which is add 3m. So I'm going to have 7m plus 2 plus a 3m equals negative 3m plus 3m plus 22. So let's simplify this. On the right hand side, let me get my other color. This negative 3m and the positive 3m is going to cancel each other out. So I'm just going to be left with 22 on the right hand side. On the left hand side, 7m plus 3m is 10m plus 2. Okay, now let's move this positive 2 to the other side. So the inverse of positive 2 is negative 2, so the inverse of plus 2 is going to be minus 2. So 10m plus 2 minus 2 is just going to be 10m, and 22 minus 2 is 20. Now let's divide both sides by 10. So 10m divided by 10 just leaves m by itself, and 20 divided by 10 is 2. So our final answer looks like m equals something. We've done all the correct processes along the way, so you know your answer is correct. You could, if you wanted to, substitute this value here, you could substitute m equals 2 back into your original equation. So instead of 7m, you would have 7 times 2. And then on the other side, instead of negative 3m, you would have negative 3 times 2. And if both sides of the equations are equal, then you know you've done it correctly. We're not going to do that for now, but that is a way to verify your answer. Second one, let's have a look. This one's a little bit more complicated, but still, if we do it slowly and we follow all the correct steps, then it shouldn't be too difficult. So I've got negative 3 outside of x plus 4, all divided by 7, minus 5 outside of 1 minus 3x, all divided by 3, equals 3x minus 4. Okay, first step, there's a variety of approaches here. I'll show the one that I prefer. So let's simplify. Let me just change my color pen. Let's simplify the numerators of both fractions here. So I've got a negative 3 times x and a negative 3 times positive 4. Then the next fraction, I've got a 5 times 1 and a 5 times 3x. So let's do that just to start. So negative 3 times x is negative 3x. Negative 3 times positive 4 is negative 12. We've still got divide by 7. And we've got a minus. 5 times 1 is 5. 5 times negative 3 is negative 15x. Divided by 3 equals 3x minus 4. 3x minus 4. Okay, now let's have a look at this. Let's do the divided by 7 first. So I've got a divide by 7, and maybe I'll just draw an arrow to it over here. That's the divided by 7 that I'm looking at. So if I want to try and remove that divide by 7, I'm going to need to multiply by 7, and I'm going to need to multiply both the left-hand side and the right-hand side of the equation by 7. What that is going to look like is on the left-hand side, I'm going to have 7 times everything on the left-hand side of the equation in my second line. So I'm going to have 7 times negative 3x minus 12 over 7, and the same 7 outside the brackets times 5 minus 15x over 3, close bracket, equals, I've just multiplied the left-hand side by 7, so I need to multiply the right-hand side by 7. So 7 outside of 3x minus 4. Okay, first step, let's just simplify the right-hand side. So 7 times 3x is 21x. 7 times negative 4 is negative 28. So I'm going to have negative 28. Now let's look at the left-hand side. Again, I can draw in some lines here just to make it nice and clear what we're doing. I've got a 7 times this whole first term, and a 7 times that whole second term over there like that. So I'm not going to simplify it just yet. I'm just literally going to write the mathematical version of those two blue lines that I've just drawn in, just to make it nice and clear. So I've got a 7 times, and let's do just a big X for times. 7 times that whole first fraction, so negative 3x minus 12 divided by 7. Then a minus 7 times that whole second part. So 7 times 5 minus 15x divided by 3. Okay, next line, let's just simplify this. So the right hand side just stays exactly the same, minus 28. Once you get confident with a few of these, you can go a little bit quicker than this, and you can find some shortcuts along the way. But for the purpose of the video, I'm just going to do everything step by step. So now let's focus in on this first series of terms over here. If I've got 7, I can essentially rewrite this as 7 over 1, if that helps to multiply, and then this next 7 over 1 I can rewrite as well. It doesn't change the 7. 7 divided by 1 is still 7, but it might help you to just visualize what we're doing when we're multiplying these two fractions. So I'm going to have this first fraction, 7 times negative 3x minus 12, all of that divided by 7, and you can see where this is heading. Next, I'm just literally going to keep this. Actually, let's add in some brackets here. So I'm still going to have 7 outside of 5 minus 15x, all divided by 3. Okay, next line. Right hand side stays as it is, 21x minus 28. Now we can start to cancel some things. So this is what we were wanting to do in the first place. I've got a 7 divided by 7, so those two are going to cancel. So I'm just going to be left with negative 3x minus 12. And now let's just rewrite this second term just as it is. Again, once you get confident, you can do this in much fewer steps, but for the purpose of the video, I'll just show you step by step. Okay, divided by 3. Now, let's focus in on this divided by 3 here. If I've got to divide by 3 and I want to try and get rid of that, I need to multiply by 3 because that's the inverse of divide by 3. But I need to do that to every single term in the left-hand side and also the right-hand side. So what that is going to look like, I'm going to have 3 outside of a brackets. So 3 outside of this whole left-hand side. So what I'm talking about is this whole left-hand side like that. So I'm just literally going to rewrite it again. So negative 3x minus 12, and then I've got my fraction, so negative 5 minus 15x, all divided by 3, close bracket, and then remember we were multiplying both sides by 3, so this right-hand side I need to multiply by 3 as well. So 3 outside of 21x minus 28. Okay, now we can simplify again, and I'll again just draw in my lines. So on the left-hand side, I'm going to have this 3 times negative 3, negative 3x, sorry, this 3 times the negative 12, and the 3 times that whole fraction over here. That whole fraction is one term. Then on the right-hand side, I'm going to have a 3 times 21x and a 3 times negative 28. So we will have 3 times negative 3x is negative 9x. 3 times negative 12 is negative 36. 3 times negative 12, so negative 36. And now we've got, before I multiply this out, maybe let's write this. Well, we can multiply it out. So we've got 3 times. Actually, let's write it out so it's nice and simple. So I'm actually not going to do this multiplication yet, the third one. I'm just going to show you the process. So I've got a minus. I've got 3 over 1. And where that 3 over 1 is coming from is I'm just writing this this term over here as a fraction just to make it a little bit clearer what we're doing. Then we're multiplying this by that whole fraction. So 7 outside of 5 minus 15x divided by 3. And you can kind of see what's going to happen here. Then on the right-hand side, we've got 3 times 21. So 3 times 21 is 63. 63x. And 3 times negative 28 is negative 84. Negative 84. Okay, next line. Right-hand side, let's just keep it as is. So 63x minus 84. Left-hand side, let's focus in on multiplying those two fractions. So 3 times 7 is 21 outside of 5 minus 15x, all divided, what's going on with that line there? All divided by 3, and then I've still got my negative 9x, negative 9x minus 36, and there was a minus here, so minus that. Now let's focus in again and simplify that fraction. So right hand side stays as it is, and left hand side we've still got negative 9x, we've got negative 36, and now let's start to divide some of these. So 21 divided by 3 is just going to be 7. So I've got a negative 7 outside of 5 minus 15x. Okay, before we go any further, the whole process that we've just done, multiplying those fractions out, that could be simplified if you chose to use the highest common multiple. but I wanted to show you it step by step. That's why we're doing it just one by one, and we're doing it really slowly like this. Okay, now let's write the right hand side again. 63x minus 84. And now let's multiply this out. So I've been drawing my line, so let's draw some lines some more. Negative 7 times 5 and negative 7 times negative 15x. Firstly, I've got a negative 9x. I've got a negative 36. Now, negative 7 times 5 is negative 35. And negative 7 times negative 15 is positive 105, and we had an x there. Okay, now this is starting to become more simple, so it's basically just a matter of grouping together some like terms. Right hand side stays as it is, 63x minus 84. Left hand side, let's look at some like terms. So negative 9 plus 105 is 96x. Negative 36 minus 35 is negative 71. Okay, let's bring this positive 63x to the other side. So 96 minus 63 is 33x minus 71 equals negative 84. Now let's add 71 to both sides. So negative 84 plus 71 is negative 13 equals 33x. Now let's divide both sides by 33. So x equals negative 13 divided by 33. Negative 13 divided by 33. And let me just have a quick check. Negative 13 divided by 33. It's negative 0.393939. So you could write it as x equals negative 0.39 recurring, or you could keep it as the fraction, either or. Okay, I know that was a long one, and definitely you can simplify some of these steps in this second example, but I just wanted to show you step by step exactly what we're doing and the thought process behind each of those.